Welcome, students. Today we are going to talk about the properties of logarithms. You should have been discussing logarithms in class quite a bit. You should also have a pretty solid understanding of your exponent laws. If you don't, you might want to go back and review those, but I'm just going to start with a brief introduction, just stuff that you should already know. What are logarithms? What do they do? Well, logarithms are just a sort of way of representing certain exponential expressions in equations. So say you have log with base b, log base b with some number equal to p. So what this actually is here at heart is just a different and equivalent way of writing a power, an exponential equation, right? So in this case, the base is going to be what's on bottom. That's why it's the base, bottom of the pyramid, right? So this is the base of your power, and it is raised to p power, base, bottom, p power, and that is equal to some number n. So these two equations are functionally equivalent to each other. They're just two ways of expressing the same idea. Sometimes you're going to want to use logarithm so that you can isolate your exponent, isolate that power number, right? So that's really what it's used for. But just as an example, to just kind of show you what I'm talking about, it makes a little bit more sense. If you have some exponential equation, say 3 squared equals, we all know what that equals, that's 9, right? If I wanted to represent that equation as a logarithm, it would be log base. What is my base? My base is 3 because it's on bottom, and n, my number, the thing the exponent is equal to, is going to be 9, and it's equal to that exponent, that power right there, right? So 2. So these two things are functionally equivalent to each other, right? And it can be useful for sort of thinking of it a different way, like solving equations. Like if you've got log base 2 of 32 equals x, what this is asking you is what power do you have to raise the number 2 to in order to get 32? So 2 times itself, how many times is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So in this particular situation, x would be equal to 5, right? So that's essentially what we're talking about here. That's the way that these things work, and that actually kind of shows an interesting couple of properties of logarithms. So for instance, I guess one of the more basic properties is if you've got log with a base of a and number a, well, we know what the exponent's going to be. That's going to be 1, and that's always going to be the case. So because, like, whether you have log base 7 of 7, well, 7 raised to what power equals itself? Well, any number that equals itself has an exponent of 1. So that is going to be a property. Log base a of a equals 1, right? And it also gives us another little property that we can use. I don't know, what do I want to use? We'll use orange here. Okay, so if you've got the log base b of 1, and b can be anything you want. Well, like, why? Because we're going to know what that exponent is. If the number is equal to 1, we know that the exponent is 0, because any base, doesn't matter what the base is, any base raised to an exponent that is 0, raised to the 0th power, is equal to 1. So that would be true of, say, log base 8 of 1. Well, what power do I have to raise 8 to in order to get 1? Well, that's going to be 0, and it doesn't matter. This could be 8 or it could be 82. Whatever. It's always, if it's raised to the 0 power, it's 1. So these right here, this one and this one, those are some of your more basic log properties. But let's talk about some of the more complicated ones, all right? Which none of them are really that complicated, but we'll just jump right in, okay? So here are the 3 major properties that we're going to be learning about right now. So let's just start at the top with the product property right here in red, right? So I will just go ahead and pick up my red pen there. Okay. So what is this property, what is it telling us? So you've got log, and you've got some base, and then you have two numbers multiplied together. So log base x of a times b is equal to log base x of a plus log base x of b. So it's saying that if you have some number here that's a log, you can break it up into its factors, the log factors, with addition. So, and there's a couple of different reasons why you're going to want to use these logarithm properties. You'll notice that all of them have the exact same base. Like this property, all three of these properties are only going to work if the bases are the same. And we'll learn in the future what to do if the bases are different. But right now, we'll just start with the basics. But this will help us solve equations, condense, expand. But let me just kind of jump in and show you what I mean. Right? We'll apply this real quick, show you an example. So if we've got log, say base 2 of 8, well, yeah, we'll go ahead and start with a condensing problem. So log base 2 of 8 and log base 2, because the bases have to be the same, of, say, 4. Well, according to our product property, since we are adding, because, yeah, these work in both ways, it's an equation, if we're adding two logs together and they have the same base, the base of x, right, base of 2 over here, we can simply multiply those numbers together. So this would become, I'll write it down here on this line so you can kind of see my steps, log base 2, it's going to stay the same, of 8 times 4, right? Which we know what that's equal to. That would be 32. So log base 2 of 8 times 4 is 32. So this entire expression right here is going to be equal to this much smaller expression right here. That's why it's called condensing. It was large and we condensed it into something smaller. And actually, once you get to this point, we can really think about how to make this true. And I think this is actually an example I used just a little bit ago. So this is saying that I have 2 raised to some such and such a power, and that is equal to 32, which, as we saw previously, in this case, x would be equal to 5, right? Because 2 times itself 5 times is equal to 32. So, but you know what? Actually, there's a way that we can think about this. Let's think about what these two components actually are. Because look, we know what log base 2 8 is. Because okay, so what number? Let me just draw an arrow here. What number do I raise 2 to in order to get 8? So 2 raised to what power gets 8? Well, we know that that's the third power. So log base 2 8 is 3, and so what power of 2 equals 4? So 2 raised to what power equals 4? Well, that's 2. So what I actually have here, let me just put an arrow, is 3 plus 2, which equals log base 2 of 32, which we just saw is equal to 5. So 3 plus 2 is 5. Does that make sense? Yes, it does. Which, towards the end of the video, I'm actually going to be proving these, but right now I just kind of want to show you how this stuff works. But if you're interested in seeing why this happens, it has to do with exponent laws, and I will prove that to you closer to the end of the video. But let's go ahead and practice something by ourselves, right? At home, so we get a better understanding. So if I've got log base 4 of 64, I want you to go ahead and pause the video and see if you can expand that. And I mean, I guess for fun, you can see if you can solve it as well. But just, I want to see what this can expand into, because it works in both directions, right? I start with an expansion, I condensed it. Think of some factors of 64 that you can break this up into. All right. So, assuming you paused the video and you did the work, there's a couple of different options that we have here, and all of them are going to work. We can break this down to the basic common factors if we really want to, or just really anything's going to work here. So, let's see. I know that 8 times 8 equals 64, so I can say log base 4 of 8 plus log base 4 of 8. And that would be one example of expanding this. And this can actually expand even further if we really, really want to. But I think you get the idea. Alright? So, let's take this and go ahead and get rid of that. And we'll move on to our next rule, which is the quotient property, which is very, very similar, right? Very similar. It says that if you have two numbers that are being divided on your log, you can expand that into a subtraction problem. So log base x a over b is equal to log base x a minus log base x b, and it works in both directions. We can go both ways with that. Okay, so let's think about this. Let's look at an example. I want to change my color here. There we go. All right. So say we've got log base 2 of 8. No, we're not going to do. We're going to do something better now. We're going to change up our numbers a little bit. Don't want to use the same numbers over and over again. All right, so log base 3 of 27 minus log base 3, because we got to keep the same bases, of 9, and we're gonna want to condense that, see what's equal to, and we can actually solve it, right? So we're subtracting these two logs, which means that we can take these numbers and we can divide them. So this is going to be log base 3, going to keep the same base, of 27 divided by 9. And in this case, the quotient property, just like in ordinary subtraction and division, order matters. Your first is going to be your numerator, your second is going to be your denominator, but we know what that's going to be equal to, right? 27 over 9, 27 divided by 9, well, that's going to be 3, log base 3 of 3. So that would be the condensed version of this, but not all the way simplified, right? Because this was one of our first properties. This is saying, so 3 raised to what power is equal to 3? Well, anything raised to the first power is itself. So actually, this would completely simplify down to 1 in this case. But let's look and see if it really does make intuitive sense here. Okay, so what number? So 3 raised to what power equals 27? That's essentially what this is asking us. So 3 times 3 is 9, and 9 times 3 is 27. So that would be 3. This entire well, I didn't circle it quite right, but this entire part of the expression is going to simplify down to 3 minus. Okay, 3 raised to what power equals 9? Well, 3 squared equals 9. So the log base 3 of 9 is equal to 2, and we know that 3 minus 2 equals 1, which is the same thing that we got over here, right? We got 1 in both cases. So that's just kind of a little bit of evidence about why this works out the way it does. And once we start throwing in variables, it's going to work the same way. But let's move on. I don't want this video to be too long, so let's look at the products. Oh, wrong one. Okay, the product property. And let's go ahead and get rid of. Or sorry, power property. All over the place here. I'm going to use green here for our power property. All right. So whenever we're talking about our power property, it's saying that if you've got the same base in both cases, and you have some sort of power inside your logarithm, so m raised to the p, this exponent here, we can actually move this exponent out in front of the logarithm. So the p moves out in front. Now let's see what that looks like in practical application here. So let's go with 2 log base 4 to the 16th power, and let's like show that it works both ways. Let's go back and go ahead and put this into an exponent. So this 2, since it's already in front, we can actually, if we want to, we can move that up there and find that log base 4 is, okay, so 2 times log base 4 16th is log base 4 16 squared. So let's see, what is 16 squared? 16 times 16, we got the 6, carry the 3, 9, 0, so 106. So if we do that, 256. So this is equal to log base 4 256. Right? And like I say, you can go both ways. This 2 can just drop down in front, and you can work both ways on every problem with expansion and condensing. But let's just let's see what this actually is saying to us here. So if we take this log base 416 and we kind of like separate it from this 2, we can think of it this way: 4 raised to what power equals 16? Well, 4 squared is 16, so that would be 2, right? And this 2 times 2, because all that is just 2 times 2 equals 4. So theoretically, this answer is saying that 4 raised to the 4th power equals 256. I mean, we can see if that's true. So like 4 times 4 is 16, times 4 is 64, and 64 times 4 is 256. So yeah, it works in that case as well. And I hope that satisfied you. You just learned 3 kind of major logarithm properties, and 2 real basic ones at the beginning. I think I'm going to end the video here, and I'm going to do another video that sort of proves these. You can see that they work by these problems that I've shown you, but I'm going to actually prove them in another video. And you feel free to watch that if you want to develop a better intuition and a better confidence in what it is that we're doing here. All right? I'll see you in the next video.